In my 14 years of journey as an IIT JEE Maths faculty, I have seen students facing a lot of problems, especially in questions of summations in Binomial Theorem. So in this video, I am going to simplify your life by giving you 5 different kinds of questions and 5 different types of tricks how to solve those 5 different types of questions based on series in Binomial Theorem. So without any further delay, let us start with it. The next problem type is constant into binomial coefficient. Let us look into a very typical question. This talks about 1 into NC1, 2 into NC2, 3 into NC3. So largely speaking, what I am going to tell you is a 4-step algorithm in solving this problem type, also the next problem type, and then I will give you a shortcut to solve all complex problems based on coefficients into binomial theorem. Now let us look into the first idea. If I want to do my first part, I will first write my general term. This is my first step. The general term in this case will become R and CR. This is my first step. In the second one, I am going to apply a property. So what is the property I am going to apply is NCR is equal to N by R, N minus 1, CR minus 1. So there are 2-3 properties that are especially important. Now, if I substitute this value in the general term, my general term becomes N by R, N minus 1, CR minus 1, R gets cancelled out. In the third step, I am going to rewrite series back. If I am rewriting series, in the first time the value of R was 1. So I will put that value. So the first term will become N into N minus 1 C naught. Second term will become N into N minus 1 C1. And it will keep on happening. The last will become N into N minus 1 Cn minus 1. So now you can take N common and write this down as N minus 1 C naught, N minus 1 C1 till N minus 1 Cn minus 1. Once you have done that, in the fourth step, I am going to use the standard result that we just did. We know that there was a standard result NC naught plus NC1 till NCn. This was equal to 2 raised to the power n. So in this, if I replace n by n minus 1, again the idea of substitution. So it becomes n minus 1 C naught, n minus 1 C1, n minus 1 Cn minus 1 will be equal to 2 raised to the power n minus 1. If we do this, our result of this series will become n into 2 raised to the power n minus 1. This is my final answer. So this is a 4-step process that you can use to solve the next 2 problem categories, this and the next one. Now let us take one more question. What happens if there is an alternate plus minus sign? So let me write my first step, that is general term. If I write my first step, it will become R into NCR. But now we have minus 1 raised to the power R minus 1 as well. Because if I put 1 in this, the first term will have plus sign. If I put 2 in this, the next term will have minus sign. So you can see that this extra term came. Second is to apply the property, and this part will remain same. So in the same one, I have applied the property. This will become N by R, N minus 1 CR minus 1. R gets cancelled out. This becomes minus 1 raised to the power R minus 1 N into N minus 1 CR minus 1. Third step, we rewrite the series. If I rewrite the series, n can be taken common. The first term becomes, if I put R as 1, n minus 1 C naught. The next one will become n minus 1 C1. The next one will become plus n minus 1 C2, and it will go till the last term. See, now in the fourth part, we will use a standard result. If you remember, there was a result. If you have NC naught minus NC1 plus NC2, this kind of a series with alternate plus minus sign and binomial coefficient, the answer was 0. Even if I replace n by n minus 1, the answer is not going to change. Still comes out to be 0. So if I put it in my series that is given to me, this becomes n into 0, hence the answer becomes 0. Now you can see that this is largely going to happen with all these constant into binomial coefficient kind of series wherever there are alternate plus minus sign. So such kind of questions I do not even need to solve. I can directly write the answer as 0. Now, if you understood this, try and solve this next question. In the step 1, we are going to write the general term now. That is now r into r minus 1 NCR. You can put the value and check for the first one and the first two terms. Second, once you have done this, I am going to apply the property. So if I apply my property, it will become r into r minus 1. We can write this as n by r. N minus 1 CR minus 1. R gets cancelled out. And then we can do the same thing one more time. Now this will become n minus 1 by r minus 1. N minus 2 CR minus 2. R minus 1 gets cancelled out. What we have got is n into n minus 1. N minus 2 CR minus 2. In the third step, we are going to rewrite the series. If I rewrite the series, what I get is n into n minus 1 will come as common. First term will start with the value of r as 2, so this becomes 0. N minus 2 C1 and this n minus 2 Cn minus 2. Now we will use our standard result. So my standard results tell me that if we have NC0 plus NC1 till NCn, the answer is 2 raised to the power n. If I replace n by n minus 2, n minus 2 C0, n minus 2 C1 till n minus 2 Cn minus 2, the answer is going to be 2 raised to the power n minus 2. So the answer of my series becomes n into n minus 1, 2 raised to the power n minus 2. So we have understood this, and now if you have understood this, you could also see a pattern that if you have plus sign, minus sign, plus sign, minus sign, the answer will come out to be 0. We don't need to solve it because in the ultimate series it is going to be plus minus sign, and for that the answer is 0. If you have these three terms 1, 2, 3, 2, 3, 4, in this what will happen? So again you can do the same process, but what you will notice is now. So let me write the answer and then let us notice. So what we did was, when we have summation of r NCR, r equal to 1 to n. So we had got this series 1 into NC1 plus 2 into NC2 plus 3 into NC3. The answer was n into 2 raised to the power n minus 1. Second, when we had summation of r is equal to 1 to n, r into r minus 1 NCR, that is 1 into 2 NC1, NC2, so on and so forth, that we just wrote. The answer was n into n minus 1, 2 raised to the power n minus 2. So you can see what is happening. So if, let us say that if we have a series from r is equal to 1 to n, r into r minus 1 into r minus 2 NCR, the answer would be n into n minus 1 into n minus 2, 2 raised to the power n minus 3. Now you can understand that if I keep on doing this, what is fundamentally happening and what kind of answers can I get. Now all of these things can become standard results to be used while solving a question. Now let us see that how to take this method and make a shortcut out of it. Once we understood this, we know that the answer of this is ultimately going to be 0. But let us see that now if I am given a non-standard kind of a thing, what I am going to do. See, now instead of following the 4 steps, I can just write the general term and apply the properties of summation. So my general term is 2r plus 1 NCR. So if I am doing sum of this, it will become summation of 2r plus 1 NCR. I can distribute the summation. So summation of 2r NCR plus summation of NCR. 2 can be taken as common. So r NCR plus summation of NCR. Now we know standard results. For this part, the result was n into 2 raised to the power n minus 1. For this second part, the answer was 2 raised to the power n. I have got my final answer. You can see that I have started using my standard results that I have figured out earlier as shortcuts for solving more complex problems. See, now it was very easy to write a general term here and then split it. Sometimes it won't be that easy. Like in this case, r square NCR. So what we are going to do is, first we are going to write the general term. So my general term is going to become r square NCR now. Second part, I am going to use partial fraction now. So what I am doing is I am trying to break it down in a certain way. Observe this thing, this is very important. So I will take my r square and write this as a into r minus 1 plus b into r plus c. Why am I writing in this manner only? Because these are the results that I actually know. For r into r minus 1 NCR, r into NCR, then NCR. So I am trying to write it in a certain manner so that I can directly apply my result and directly get the answer. So now how to get the value of ABC? The method is very simple. If you put r is equal to 0, you will get the constant term. So C comes out to be 0. If I want to get the value of B, I will put r as 1. So the value of B also comes out to be 1. And if I want to get the value of A, now I will compare coefficient of x or r square on both the sides. So left side it is 1, right side will be A. So A also becomes 1. So what are we saying is, in the partial fraction part is, r square can be written as r into r minus 1 plus r. See, I could also have directly written this, but then it looks like a magic. When you use partial fraction, you actually understand how to split a term in certain manner. And that is required and conducive to a question. So once you have done this, in the third part, we can again write it in the form of summation. So what we can write is, if we are writing r square NCR, this will become r into r minus 1 NCR plus r NCR. You have multiplied NCR on both the sides. And then if I put a summation, that is r square NCR, this will become summation of r into r minus 1 NCR plus summation of r NCR. Answer of this question becomes n into n plus 1 2 raised to the power n minus 2. This will become n into 2 raised to the power n minus 1. Now you can see that I have used these two standard results that were earlier questions. And the summation or the solution of this question becomes extremely short. Why this is important? Because now this answer to we know is going to be 0. But let us say that somebody has given you r cube NCR, then what are you going to do? So r cube NCR would be our general term. Second part, I am going to apply partial fraction. A into r minus 1, r minus 2, because we want to go till 3 power. Then b into r minus 1, c into r plus d. In order to find this value, I am going to substitute the value of r as 0. As a result, d comes out to be 0. Then we can put the value of r as 1. You can see the value of c comes out to be 1. Then we can put the value of r as 2. If I put the value of r as 2, this becomes 8. Then we'll have b into 2 into 1. So value of b comes out to be 4. And ultimately, if I compare coefficient of r cube on both the sides, the value of a comes out to be 1. So we have successfully applied our partial fractions in this question. Now once you have done so, in the third part, and I can write it in the form of sum. So if I have r cube can be written as r into r minus 1 r minus 2 plus 4 times r into r minus 1 plus r and then ultimately 0. So now if you have r cube NCR, this can be written as r into r minus 1 r minus 2 NCR plus 4 times r into r minus 1 NCR plus r times NCR. Now what is the benefit? Now if you put summation, that is summation of r cube NCR, this will become summation of r into r minus 1 into r minus 2 NCR plus 4 times summation of r into r minus 1 NCR plus summation of r NCR. And all of these results you know. So this will become n into n minus 1 into n minus 2, 2 raised to the power n minus 3, 4 into n minus 1, 2 raised to the power n minus 2, and then n into 2 raised to the power n minus 1. So you have got this answer in an extremely fast manner. So this becomes the power of using partial fraction in solving such kind of questions. This gives you extreme level of speed. Now you can see that similar kind of question is again given but alternate plus minus sign, so we don't even need to solve it, the answer comes out to be 0. Now you can see that sometimes there could be variations to the same question. Now you can see that what is happening here, there is a 2 raised to the power 0, 2 raised to the power 1. If they start varying the question in this manner, your shortcut will fail and you will have to go back to your original 4-step method. So what was the step 1? To write the general term. So that now will become r into r minus 1, 2 raised to the power r minus 2 NCR. You can check it whatever you have written by substituting 1 or 2 values of r and see if you are getting the first 2 terms or not. Second part, now what we are going to do, we are going to apply the properties. So that is r into r minus 1. Now this will become n by r, n minus 1 c r minus 1, r gets cancelled out. We'll apply it one more time. Now this becomes n minus 1 by r minus 1, n minus 2 c r minus 2, r minus 1 gets cancelled out. And now we have got our general term, n into n minus 1, 2 raised to the power r minus 2, n minus 2 c r minus 2. In the third step, we are going to rewrite the series. If I rewrite my series, how it is going to look like? N into n minus 1 will be out. If I start putting the value from r is equal to 2 as in the first term, so this becomes 2 raised to the power 0, n minus 2 c naught, 2 raised to the power 1, n minus 2 c1. Now we know how we can get the answer of this. For that, we are going to use our standard result. So we'll have to, whenever the question is complex, we'll always have to go one step backwards and not one step forward. So if I have 1 plus x raised to the power n, the answer is nc naught plus nc1x plus nc2x square. So what you can clearly see that here in place of x, 2 is written, and in place of n, n minus 2 is written. If I put both of these values, this will become 1 plus 2 raised to the power n minus 2. And this becomes n minus 2 c naught. And now if I substitute these values, you can clearly see that the sum of the series that we are searching was n into m minus 1. And for the remaining part, the answer came out to be 1 plus 2, that is 3 raised to the power n. You can see that slight variation in a question, and I will have to go back to the original method or 4-step method of solving questions. 60 days to JEE Mains. Let me tell you something that nobody else will. The brutal truth. Right now, you have doubts from class 11th you never cleared, topics you are avoiding, formulas that you kind of remember, and you are thinking 60 days is enough to fix everything. Here's the reality. It's not if you study randomly. At PracBee, we have produced 10 times better result than national average and helped more than 500 plus students jump 80 plus marks in last 60 days. How? They stopped trying to cover everything and focused only on high weightage topics. They cleared every doubt. They had a strategy into place. And that's what Last Lab Booster program does. Senior ITN faculty sit with you and develop a 60-day roadmap. Expert teachers guide you 1:1 daily. Every doubt is cleared in 24 hours. Not random prep, but strategic warfare. Ashesh, Ditya, Sauri, Sarthak, we are all able to improve from 150 to 250 in a matter of 60 days. Real students, real result, 60 days. But time is less and our slots are even more limited. Click the link below, book a free strategy session or regret it on 1st Feb. 60 days, your move.